In this video, I will introduce power and its relationship with energy and work. Please refer to the timestamps below to see a specific problem. So what is actually power? We can say power is the rate at which energy is being transferred, or basically how fast is the energy transfer. So if we look at this equation, we can understand this better. Power is equal to work over time. We know that work is just the force times displacement. Also, we have seen in the previous videos that work is just a transfer of energy. So then power is the rate at which work is done. Let's look at the units here. Power's unit is watts. Work's unit is in joules, which happens to be the same unit we use for energy. That is because, of course, work is just a transfer of energy. And time is in seconds. So this means that 1 watt is equal to a joule over a second. Let's imagine now a 100 watts light bulb. 100 watts means that this light bulb will transfer 100 joules of electrical energy every single second. So now that we have all the equations and we understand the concept of power, we can move on to some problems. Problem number 1. A 35 kilogram crate is lifted 100 meters above the ground in 6 minutes. What is the average power exerted on the crate? So for every problem, I like to start by drawing the situation a bit to understand what is happening. Here we have a crate that is being lifted 100 meters in 6 minutes. So let's always start with the power equation that we just saw, which is power equals work over time. If we first calculate work, we know work equals to force times displacement. In this case, force is just the weight of the crate, which is m times gravity. And the displacement, we are told, is 100 meters. So work will equal 35 kilograms times 9.8 meters per second square times 100 meters. Or work equals 34,300 joules. Now that we have calculated work, we can just divide that by time. But we know that time has to be in seconds. So we have to convert 6 minutes to seconds. So it'll be 6 minutes times 60, that's equal to 360 seconds. So the power is just the work over time. So it's 34,300 joules over 360 seconds. That is equal to 95.27 watts. So now we can actually move on to problem number 2. A certain rain cloud at an altitude of 1.85 kilometers contains 3.10 times 10 to the 7 kilograms of water vapor. How long will it take for a 2.7 kilowatt pump to raise the same amount of water from the Earth's surface to the cloud's position? So again, I am going to draw a small sketch here of what is happening. We have the cloud that has a mass of 3.10 times 10 to the 7 kilograms. We are asked how much it will take for a 2.7 kilowatt pump to raise the same amount of water vapor. So here we can just convert the kilowatts to watts, since we know that's the unit we can use for the equation. So that is 2,700 watts. Now that we have power, all we need to find is the time. So we can rearrange the equation. That time will be equal to work over power. We can first calculate work again, just like in the previous problem. Work equals mass times gravity times displacement to raise or lift an object. So for this problem, we have mass equals 3.10 times 10 to the 7 kilograms times 9.8 meters per second square. And then we have to change again 1.85 kilograms to meters, which is 1,850 meters. So the total work is 5.6 times 10 to the 11th joules. Now let's divide work over power to find the time. So that will be 5.6 times 10 to the 11 joules over 2,700 watts. And the time will be equal to 2.08 times 10 to the 8th seconds. That is such a big number. Just for fun, we can actually convert that to years. So all we have to do is multiply the seconds times 1 minute over 60 seconds, so that we can convert to minutes. Then we multiply by 1 hour over 60 minutes. Then we can multiply times 1 day over 24 hours, and that times 1 year over 365 days. That way we can eliminate all of the other units and we will keep only years, that will be equal to 6.60 years. So now we can move on to the third problem. An 820 Newton soldier is in basic training climbs a 12.0 meters vertical rope at a constant speed in 8.0 seconds. What is his power output? This one is actually very easy and straightforward. We have the force, the displacement, and the time. We just need to plug it into our power equation. So power equals work over time. We know work is force times displacement, so 820 newtons times 12 meters over 8 seconds. The power output equals 1230 watts. I hope you're able to solve problems related to power and work now for your physics courses. Please let me know if you still have any questions related to these problems we just solved in the comment section below. Thank you so much for watching.